Hi everyone, this is our tutorial number 5, and today I wanted to show you how to make box plots. Okay, so what's a box plot? This is a increasingly popular way of graphing your data. And essentially what it is, you can see maybe why it's called a box plot. We have a box in which your data is displayed. Okay, so the way it works is you'll see a box with a black bar running horizontally through the box. Typically that is the median value of your data. Okay, so not the mean, but rather the median. Then you'll see you have this box that has bounds. Okay, and the bounds of that box essentially cover 50% of the values in your data. Okay, so 50% of your data is falling in the boxes. Okay, then you have these little, what are called whiskers, so it's called also can be called a box and whiskers plot. So these two whiskers show the remaining 50% of the data, for the most part, 25% above and 25% below. Okay, so this is the middle 50%. And then these are the upper and lower limits. And in some cases you have data that are deemed to be outliers. Okay, and those are shown as points outside of the actual box and whisker plot. Okay. So you can start to see here a little bit why people are starting to prefer box plots over, say, a bar plot. So whereas a bar plot is simply just going to plot your mean data value, the box plot is giving you much more information. It's not only showing you sort of where the median of your data is falling, but it's showing the distribution of your data. So if this box was very small, say just spanning the area that my cursor is now covering over, we would see that there's very little variation in the data. But if the limits of the box were much larger, say covering this range, we would say, oh wow, there's a lot of variation in the data. Whereas here we can see there's kind of medium variation in the data. Okay, so this is a nice way to display your data. Okay, so how do we do this? I've made a fake data set. I tried to model this off the kind of data you might have as you're doing this project. So you might have, say, year. I just picked 2016. You might have a country. In this place, in case these are planets. These are Star Wars planets. And then I just made up data on, say, the percent of bacterial isolates, bacteria isolated from humans that were found, well, humans, aliens, whatever, found to be resistant to antibiotics. Okay, we have year, country, resistance, and then this is repeated for a second, planet. Okay, in this case, Tatooine. All right, so I'm going to save this as a .csv file. I'm going to call it planets. I'm going to save it, and I'm going to go back to R. Okay, so I'm going to see what my working directory is. Okay, that's not what I want. I want it to be on the desktop, but within the RTutorial folder. So you can see R is very sensitive to spaces. I forgot a space. Now that should work. Let's double check. Okay, so now I can import my data. So I'm going to assign it to the name planets. Okay, so again, we're saying R, you're going to know this data file is planets. We're going to read in this CSV file called planets.csv, and there is a header, meaning, again, in Excel, I have column names. Okay, let's run that. Let's see what my data looks like. There we go. Okay, now I want to do just a summary of this data because it's a little bit hard to look at. And it's telling us, okay, you have 3 columns with year, planet. Each of those have 17 data points and the percent of isolates resistant. Now I want to make a box plot. And specifically I want to ask, do my planets differ in the frequency of antibiotic resistance? So we're going to really ignore year and just ask about overall frequency of resistance between the 2 planets. Okay, so we're going to say we don't care if it's changing over year. We just want to know, is there more antibiotic resistance on Naboo versus Tatooine, or vice versa? Okay. So we type box plot. Pick our dependent variable, which in this case is percent isolates resistant. And so notice what I'm doing here. I'm saying I want the percent isolates resistant column, which is part of, sort of appended to, my planet's data set. Okay, so that's my dependent variable. And then I use this tilde to say I want to plot my dependent variable as a function of the planets column. Okay, so this is a little confusing. That's the planets column, which is within the planets data set. Okay, there we go. So again, as always, we have some visual things. I want to change the size of the axis values. I want to increase the line width so it just looks a little bit better. I'm going to add a y-axis label. Okay, that's proportion of isolates resistant to antibiotics. And that's way too small. So I'll make that a little bit bigger. And of course, as always, it's falling outside of our margins. So we're going to change our margins. And I want to make it so that my y-axis values are not oriented in the way that they are. Okay, now, so all of that's much easier to read. And you don't need to do this because it's pretty clear, but you could change the colors of the boxes if you wanted to. So let's say we'll make Naboo tomato, Tatooine sky blue. There you go. So that is a box plot. And again, just notice what we're seeing is we can compare the median values, so the median level of antibiotic resistance or frequency of resistant isolates in Naboo versus Tatooine by comparing the black bars. Then we can also see the extent to which our data overlaps by looking at these boxes. Okay, so we can see that on average, Tatooine has lower levels of antibiotic resistance, so we just compare the 2 boxes, but there are some times when Naboo has very low levels. Okay, so we really get a nice sense of the distribution of the data. Okay, now I'm going to, of course, save this R script as planets, and we can come back to that. Okay, that's all for now.